All right, so what we're going to look at here in this example is we're going to start with data, and we're going to go through pretty much everything that we've learned about scatter plots, line of regression, those four questions from start to finish with one example. Okay, so this is all going to be printed. I'll kind of run through all of the steps and everything that I'm doing. And again, I'm focusing on putting in a lot of detail in order to answer your questions, to maybe fill in the gaps, to maybe show everything that I'm thinking and I'm putting it on the page. When you actually go to do this yourself, it won't take as much space, okay? But I'm intentionally kind of being a little verbose um, and using some extra illustrations to try and make my point, or to teach you this. So let's look at this example. So data about third exam and final scores were collected from students in a statistics class. So this third exam scores, these are going to be our X values, and the final scores are going to be our Y values. So we want to determine the following. Part A, does the line of regression estimate the sample data with at least a 95% confidence level? Okay, that's our question 3. Question 4 is, does the sample line of regression model the population line of regression with a 95% confidence level? Okay, so regardless of answering questions 3 and 4, one still needs to proceed through the previous steps of preparing the data and answering questions 1 and 2. So in preparing the data, you want to identify which is the independent variable and which is the dependent variable. So the independent variable is going to be the third exam score. Those will be our X values. The dependent variable will be the final scores, which are going to be our Y values. Now, are there any outliers here? So, typically, one would look for, identify, and even remove outliers at this step, but outliers are not covered until 12.6, so we're going to skip this step for now. So questions 1 and 2 involve the determination of the equation for the line of regression, okay, which is y hat equals ax plus b. A is the slope, b is the y-intercept, and the correlation coefficient, and the mean point, x bar, y bar. All right, so to get these things on the Texas Instruments calculator, you'll put the third exam scores into list 1 and the final scores into list 2. Okay, so we come over here, just go to stat, go to the list editor. Okay, the third exam scores are in list 1, the final scores are in list 2. And then we want to run 2 variable stats. That's going to give us x bar, y bar. So let's come over here, back to our calculator. If I click the stat button, go to calc, then the second option is 2 variable stats. So click enter. Okay, list 1 is our list of x values. List 2 is our list of y values. So I'll hit calculate. And so this gives us x bar, which is 69.18, and y bar, which is 160.45. And you can see those are the 2 values that I've got here. Okay, so this is the point that the line of regression is going to go through. So now we need to calculate the line of regression using the calculator. So we need to come up with the slope and the y-intercept, and we need the correlation coefficient. So to find that with the Texas Instruments calculator, we will, let's see here, we'll quit out of this, click on stat, go to calc, and then go to linreg ax plus b, and click enter. L1 and L2, we're not going to worry about storing the regression equation for right now. We'll just hit calculate. And here you can see it gives us a slope of 4.827 and some change, a y-intercept of negative 173, and a correlation coefficient of 0.663. And you can see off to the right, those are the same values that I calculated and that I've got printed here. Okay, so our slope of 4.8274 goes in front of our x, and then we've got minus 173.51 with a correlation coefficient of 0.663. To do the same thing on the NumWorks calculator, what we want to do is go to the regression app, click OK, put your data, so the third exam scores in X1, the final scores in Y1, and then we'll go to the Stats tab, click OK, and this will give us, X bar and Y bar, because this is in the row which calculates the mean, right? So the mean of X1, Y1, of X is 69.18, and the mean of the final scores is 160.45. All right. And again, that's what we had over here of 69.18 and 160.45. All right, so now let's get the line of regression. We need the slope and the y-intercept. So what we're going to do is go back, and now we're going to go to the Graph tab. Click OK. So it's going to show us our scatter plot. Now, just from the scatter plot alone, it's giving us the correlation coefficient down here. So you could write this down if you wanted to. But what we're going to do is, right now, this point is currently selected. I'm going to move up to get into these graph controls, and I'm going to go over to regression, click OK. I want a linear regression, and I'll do it in this format with mx plus b. So I'll click OK. And now it's giving me the x bar, y bar. All right, that's our mean point. And let's see if I hit up. Let's see if I hit down. If I hit down again, okay, if I hit down twice, you can see it's giving me the line of regression equation with the slope and the y-intercept here. If you needed these two values also, you can get it in the Stats tab. So let me show that to you really quick. So if I hit the up arrow to get up here to these tabs, and I go back to the Stats tab, what you'll notice now as we scroll down, there'll be a new row which has this one that says regression. And so we're doing a linear regression, which is y equals mx plus b, and m, which is our slope, is 4.827394, and b, which is our y-intercept, is negative 173.5. Okay, so it gives us these values here as well. And what's advantageous of having the values here is that if you needed to store these in a variable and use them to calculate later, you can do that here. And you can put that maybe in letter M, if you need that later. Okay. All right. So using both calculators, we got the mean point, x bar, y bar, and we got our line of regression, and we got the correlation coefficient of 0.663. So because our correlation coefficient of 0.663 is between 0.60 and 0.799, the strength of the linear correlation is strong. And I'm basing this off the literal translation table that was in the previous section. So we've got a strong line, strong correlation between the third exam scores and the final scores. So here's a visual of what we've completed so far by finishing questions 1 and 2. So we've got this scatter plot We found the mean point, okay, which is X bar, Y bar, and those are the values. We calculated the line of regression, and this is the equation for the line of regression. So one thing to note here is that's great, and we found that this fit is strong to this scatter plot. But what we want to kind of notice is that if a student scored a 68 or a 73 on the third exam, we do not have a data point to estimate what the final score would be. So notice down here at 68 and 73, as you go up from 68, we don't have a data point here. We didn't have a student that scored a 68. And likewise, we didn't have a student score a 73 either. Okay, but you may want to ask yourself, well, what if a student did score 68? What could we predict that their final score would be? So because you have a line of regression, you'd go up from 68 until you hit the line of regression, then you'd go over, and where it intersects the y-axis, that would be your predicted score. So with a student that scored a 68 on the third exam, you can see we would maybe get around 155 on the final. And if a student scored 73 on the third exam, looks like we would score maybe close to 180 on the final. All right, but see, that's making a prediction. What is that number? And can we use this line of regression to make that prediction? Is this line of regression good enough for that? So that's kind of what I just said. It says if one knew the line of regression was a good enough estimator, then one could use it by plugging 68 in for X and then calculate Y. And that leads us to question 3. So this is what question 3 is designed to determine. Does the line of regression estimate the sample data with at least a 95% confidence level? So let's answer question 3. So for question 3, you want to draw the following illustration. So you want to put this number line, which is a number line that represents correlation coefficient values. So remember, the correlation coefficient can be a number between -1 and +1. And for scale, I'm putting 0 in the middle in between those two. And what we need to calculate is we need to calculate this R critical value, both positive and negative. And let me use a different color here. So we need to calculate this positive R critical value and this negative R critical value so we know where to draw these two boundaries. And those boundaries separate what we consider to be a good estimator or bad estimator, whether it passes a 95% confidence level or fails it. Now, at this point, this R critical value is unknown. We don't know what it is. But in the previous step, we did get our sample correlation coefficient. That was 0.663. So we got that. But we don't know whether it's going to be on this side of the critical value or that side of the critical value because we haven't determined that yet. So what we need is this R critical value. And that's where this custom program I made comes into play. So what you need is a sample size and you need a significance level. Okay, so sample size, how many datums do we have? So let's scroll up. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We have 11 rows of data. So let's run this program. We'll do it first on the Texas Instruments. So let me come over here. And so we'll go to Program. We want the rcritval program. right there. Click enter once, click enter again to run it. Sample size was 11. Now we're testing this to a 95% confidence level. So if the confidence level is 0.95, the significance level is going to be 0.05. Because remember, the confidence level and the significance level should add up to 1. So we hit enter. This will be two-tailed. So select that. And then it calculates a positive and negative R critical value of 0.602. Now, to do the same thing with the NumWorks calculator, again, I can't load this program into your NumWorks calculator in the same way. So I created a MyOpenMath problem that you'll have access to on your homework and the exam, and this is what it's going to look like. So let me kind of flip over to that really quick. All right. And you can see it essentially it has the same inputs. Okay, we have a sample size of 11 with a significance level of 0.05. And then you hit submit, and you see we get 0.602. So we get the same answer. And if you have values in here from a previous calculation or problem, just hit try a similar question, and then it'll reset it. Okay. So anyway, sample size of 11, 0.05 for a significance level. Hit submit, and we get 0.602. Okay. So we get 0.602 here, we get 0.602 here. So let's fill in our R critical value and our R samp into the number line above. So you see we have the same figure that I drew in earlier, but now what I've done is I've got some clarity now, okay? So we now know that the R critical value is a positive 0.603 and or 0.602, I put 0.603. Okay, but we have both of those values, which sets the boundary here and here. Now the correlation coefficient of our sample was 0.663. So notice that 0.663 is greater than 0.603 or 0.602. And so that lands this correlation coefficient clearly on this side of the border. And so that makes the line of regression that we've got considered a good estimator of the data. So question 3, is the line of regression a reliable, good enough estimator of the data? And the answer is a clear yes. So since the correlation coefficient of our sample is greater than the positive R critical value, it turns out the line of regression is a good estimator of the sample data with a 95% confidence level. So what does this mean? This means the line of regression can be used to estimate values within the range of X values. So it can be used as an estimator. So because it could be used as an estimator, we can use it to estimate final scores now. So we can use it to estimate the final score of a student who scored a 68 or a 73 on the third exam. So what we do is we can substitute 68 and 73 in for X. So, here we have our line of regression that we calculated previously. And we're going to take this value of 68 and plug it in for X right there. And we're going to take this value of 73 and we're going to plug that in for X right there. And we then just kind of simplify this expression on the right, simplify that expression on the right, and you would get 154.7532. I'm just going to round that to 155. So when we put X equals 68 in to our line of regression, we get Y equals 165 out. So when we put 68 for X in, we get 155. Oops. When we put 68 in, we get 155 out, which is kind of what we expected. I got kind of lucky there. And if a student were to score a 73, if we plug 73 into our line of regression, then we get a value of 179 out. So a student would probably score, with a 95% confidence level, a score of 179 on the final. So, just from 11 students, we can create a line of regression that could be used to predict the scores of other students and with other scores, which is pretty powerful stuff. So let's come down to, let's see here. So I've got answering question 4. So let me go ahead and stop this video here. We'll pick up the next video answering question 4 here. All right, let me know if you have any questions.